The solution of linear equation is somewhat procedural. You just need to follow some steps to obtain the solution of a differential equation which is found to be linear. In our introductory discussion of differential equation, we discussed already how to identify whether the equation is linear or not by taking the three requirements such that the first one is that the degree of the dependent variable and its derivative should only be 1. There should be no products of the dependent variable and its derivatives. And the third one is that there should be no transcendental functions of the dependent variable and its derivatives. Okay? So the first order differential equation in the form a1 as a function of x, the first derivative of y with respect to x, plus a sub 0, a function of x times y is equal to g of x, is said to be a linear equation in the dependent variable y. If you will be checking all the three requirements, then this differential equation satisfies all those requirements, and therefore this is linear in the dependent variable y. So the coefficient is just a function of x. Even though there would be transcendental functions, it will only be a function of x and not of the dependent variable y. The standard linear form, or let us call it SLF, a shortcut, if we have the dependent variable y, is this form. The derivative of y with respect to x plus p as a function of x times y is equal to q of x. Take note, in the given differential equation, it is not always y as the dependent variable. If you check that the equation is not linear with y, maybe you can check, maybe it is linear in x. And if it is linear in x, the standard linear form would be this one. The derivative of x with respect to y plus p as a function of y times x is equal to q as a function of y. That would be the standard linear form. But for this discussion, let me show you the solution for this equation in which we have y as the dependent variable or the linear variable. So again, remember that we are talking of the derivative of y with respect to x plus p as a function of x times y is equal to q as a function of x. You need to identify what is p of x because p of x will be used in finding the integrating factor. The integrating factor is simply e to the integral of p dx. And that integrating factor is to be multiplied to our SLF. This is our SLF. So if we multiply e to the integral of p dx to this SLF, this is now the resulting equation. And then we multiply it by dx. So this times dx, so mawala dito yung dx, ito magkaroon ng dx, and then also the right side with dx. Then we introduce a new variable u. Let u equals integral of p dx. If u is integral of p dx, then du is p dx. If you are going to look on the first term, e to the integral of p dx, so that would be simply e to the u dy. On the second term, e to the integral of p dx again is e to the u. Then you have here p dx is du. And then you have here your y. So that would be y e to the u du is equal to the right side. Let us not replace the right side. We are actually interested on the left side of the equation. Because after you multiply the integrating factor and dx to our standard linear form, you should always arrive at a point that the derivative of the product of the integrating factor and the linear variable should be equal to this left side of the differential equation or the solution that we have formed. So checking the derivative of e to the u times y is what? Derivative of product. E to the u dy plus y times derivative of e to the u is y e to the u du. So we just replace this left side by the derivative of e to the u times y. It should always be. If you cannot put the left side of the equation into the derivative of the product of the integrating factor and the linear variable, there is something wrong with your solution. Maybe with your integrating factor, or maybe the way you simplify your equation, or maybe the way you formed your standard linear form. And after that, after replacing it, you just integrate both sides of the equation. And our general equation will be this, that y e to the integral of p dx is equal to the right side q e to the integral of p dx plus c. You may want to remember this as yes p dx, this is with integral, sa quest p dx plus c. That is the manner in which my previous students remember linear differential equation. They read the integral as s. So this is yes p dx sa quest p dx plus c. That is the solution for linear differential equation if you have y as the linear variable. So if you have x, then you just replace the variables. You have here x e to the integral of p dy is equal to the integral of q e to the integral of p dy plus c. That is if x is the linear variable. Maybe again, you don't appreciate or you don't understand the method of solution because there is no numerical value given, because this is the general solution. So for you to understand the method of solution for linear DE, let me give you the next slide for the first example. Okay? Solve the equation derivative of y with respect to x plus y over x is equal to x to the fourth. So this is already in standard linear form. But to show that it is really the standard linear form, again, recall that our standard linear form is the derivative of y with respect to x plus p as a function of x times y is equal to q as a function of x. So you have here the derivative of y with respect to x plus 1 over x times y is equal to x to the fourth. So what is our p of x? So our p of x is 1 over x. So this is our standard linear form, linear in the variable y. And the next step is to find our integrating factor if, which is equal to e to the integral of p dx. So that is equal to e to the integral of 1 over x dx, or simply equal to e to the ln of x, or simply equal to x. Okay? Then, the next step is to multiply our SLF with our IF. Then the next would be to multiply it with dx. So let us also have here times dx, so that it will just be one step. So you have x times our SLF, derivative of y with respect to x, plus 1 over x times y is equal to x to the fourth, and we multiply also with dx. So simplifying, you have x dy plus y dx is equal to x to the fifth dx. Again, after having this multiplication, you should check. But the derivative of the product of the integrating factor, so we have x and y. Y is our linear variable. What is the derivative? That is x dy plus y dx. And as you can see, this is exactly the left side of the equation. Again, that should always be the case, that after multiplication, the left side should just be the derivative of the product of the integrating factor obtained and your linear variable. So after that, we just replace the left side. Then that is just the derivative of xy is equal to x to the fifth dx. Then we just integrate both sides of the equation. And therefore, you have xy is equal to x to the sixth over 6 plus the constant of integration. Or simply, x to the sixth minus 6xy is equal to c. And that is the solution of our linear differential equation given. Did you get the flow of solution? So again, remember that you have to express first the given dE in a form of standard linear form. After that, find the integrating factor equal to e to the integral of p dx. And then after that, you multiply your if with your SLF and the derivative of the independent variable. In our example, it is x. Then, the left side of the equation should always be equal to the derivative of the product of the dependent variable or the linear variable and the integrating factor. Then you just take the derivative of both sides of the equation. Okay? So the next example, solve the equation y prime plus y cotangent of x is equal to x. Let us check first if it is linear. So as you can see, first order or first degree, everything. There is cotangent, but it is the cotangent of the independent variable. So that is still okay and make the differential equation linear. So expressing it in standard linear form, you have the derivative of y with respect to x plus cotangent of x times y is equal to x. So this is our p of x, cotangent of x. Therefore, our integrating factor is equal to e to the integral of cotangent of x dx. Okay? And what is cotangent? Cotangent is e to the integral of cosine x over sine x dx. And if you let u to be sine x, your du is cosine x. So this is equal to e to the ln of sine x. So that is e to the ln of sine x, or simply equal to sine x. That is your integrating factor. Sorry. Then after that, you multiply again your if with SLF and dx. So SLF times if times dx. So you have sine x dy plus, again, cotangent is cosine x over sine x times sine x. So remaining now would be cosine x times y dx is equal to x sine x dx. Okay? Then, the left side again, let us verify if the derivative of sine x and y. That would be equal to what? Sine x dy plus y cosine x dx. So you have here sine x dy and y cosine x dx. So the left side is okay. Which is equal then to the derivative of, nahin natin yung y, sine x is equal to x sine x dx. Then we integrate both sides of the equation. So integrating, you have y sine x. How will you integrate this? Integration by parts. If you let u to be equal to x, your du is dx. And our dv is sine x dx. And where v is negative cosine x. So that is equal to uv. So negative x cosine x minus the integral of v du. So minus minus, so plus the integral of cosine x dx. So you have again y sine x is equal to negative x cosine x. The integral of cosine x is plus sine x plus the constant of integration. So that is now our solution. If you want, you can simplify by dividing both sides by sine x. If you divide it by sine x, then what is now the solution? So we have y is equal to negative x cotangent of x plus 1 plus c cosecant of x. Do not remove 1. Do not combine it with c because c has a multiplier now of cosecant x. Or you can rearrange the term y plus x cotangent x minus or plus c, still c times cosecant x is equal to 1. And that is the solution of the example number 2, which is found to be linear in the variable y.